This is problem number 16 on page 39 of the Giancoli textbook. It reads, a sports car accelerates from rest to 95 kilometers per hour in 6.2 seconds. What is the average acceleration in meters per second per second? In this problem, I've just made a quick sketch to begin. You should recognize that a couple of things. First, that it accelerates from rest, or we could say that v naught is equal to 0, which is of course important in solving this problem. Units of meters per second, and V final is given to you in kilometers per hour. V final is equal to 95 kilometers per hour, kph. You can start the problem by converting that immediately to meters per second. You don't have to, but I think at least you need to recognize that all the units need to be aligned. If you don't do it, I'll show you the problem here in just a minute. When I convert that to meters per second, I get 26, actually not 0.2, I get 26.4 meters per second. By definition, average acceleration, or a bar, is going to be equal to my change in velocity over the time interval. In this case, I have both v final and v initial, so I can say that v final minus v initial over the time interval is going to be equal to my average acceleration. Of course, the final is this 26.4 meters per second, and I'm going to subtract from it 0 since I started from rest, and the time interval is given to me as 6.2 seconds. This gives me units of meters per second in the numerator and seconds in the denominator. Of course, the seconds cancel out, and my acceleration becomes 4.26 meters per second per second. I take that back. They don't cancel out. I get meters per second over seconds. This is a complex fraction. If I wanted to deal with the units here on this side of the line, notice that I have meters per seconds over 1. Based on how you've learned to deal with complex fractions, I can multiply by the reciprocal, so I have meters per seconds times 1 over seconds, which yields meters over seconds squared. Again, that's where that unit comes from, or I can write it as meters per second per second. In this particular problem, I need to recognize numerical significance and truncate my answer to 4.3 meters per second squared.